And how are you? How is your studies going on? Okay. Speak loudly. Okay. Yes. So in the continuation of our module of this chapter, alternating current, on the last module we have seen LCR, AC circuit containing inductance, capacitance and resistance, and we found that impedance in that circuit and phasor diagram. Now today we are going to see LC oscillation. LC oscillation means a circuit contains only inductance and capacitance. Here there is no resistance. So I am drawing a diagram here. Say here is a coil, say of inductance L is being connected a key, and here we are having a capacitor, say capacitance C. Now here we are having a cell and another key, say K1, and is being connected like this. Okay, so this is our circuit diagram. Say this is the point A, this is the point B. Okay, now draw the diagram. The capacitor of capacitance C is connected to an inductance of inductor of inductance L. We can see here both are connected. The inductor of inductance L through a key K2. Say this is and this is K1. A cell is connected here through a capacitor C through a key K1. This is our circuit diagram. Now we are going to see the working of LC oscillation. So we are doing the procedure of this LC oscillation in stepwise. In the first step, when plug key K1 on, when plug key K1 is put on, cell charges the capacitor. Here the current will flow and the cell charges the capacitor. Say a potential V barabar Q by C. It will charge. Some energy from the cell is stored in the dielectric medium between the plates of the capacitor in the form of electrostatic energy. In the form of electrostatic energy. It is clear it is due to this cell. And that energy would be represented, we know the formula of energy, that is Q square by 2C. Say this is our equation number 1, this is our equation number 2. This capacitor is charged. On removing, in the second step, on removing the plug of key K1 off and K2 on, here, this is, and putting the plug of K2, the charge capacitor here is capacitor charge, say it is positive and it is negative. This current which is flowing here, it is called charging current. This current which is flowing here, it is called charging current. The charge capacitors is connected to L, start discharging through L. It will discharging through L, and induced EMF develops in the circuit, and induced EMF developed in the circuit will oppose the growth of the current. It is clear that we have seen earlier. So that will oppose, so hence delays it. When capacitor is completely discharged, its total energy, this energy, it will completely discharge, and this energy stored in the capacitor appears in the field here called magnetic field energy, that will transfer to the magnetic field energy, and that magnetic field energy around L would be represented by that also we know, that is 1 by 2 L I square. This is our equation number 3. It is clear? Now as soon as the discharge of capacitor is complete, then what happened? Discharge current stops. discharge current gets stopped, and we can say the current which is flowing here is discharging current. Draw the diagram. Here I can say positive, here I can say negative. Now, draw this diagram and write these two states. So as soon as the discharge of capacitor is complete, discharge current stops here and magnetic flux linked with L starts collapsing. Through an induced EMF develops, which will start again recharging the capacitor, but in opposite direction. It is coming like this. So recharging the condenser in opposite direction, and the recharging is also opposed and again hence delayed. So recharging of capacitor in opposite direction, hence delays. This is the third step here. When the condenser is recharged completely, then again the magnetic field energy around L reappears in the form of electric field energy. Again this. So this converts again into this. That is in between the plates, and the entire process goes on repeated continuously. This energy goes to this energy goes to this. It's called LC oscillation. So what happened, dear children, here? Thus, energy taken once from the cell, the energy once taken from the cell and give to capacitor keeps on oscillating in between C and L. So energy oscillates in between C and L. If I suppose that if the circuit has no resistance, there is no resistance, so we can say no loss of energy would occur. Here there is no loss of energy. No loss of energy is there. So the oscillation produced will be of a constant amplitude. The oscillation which produced here is in a constant oscillation. It is a constant oscillation produced here. And this constant oscillation and constant amplitude. This oscillation is in a constant amplitude. So when the amplitude is constant here, so we can say the oscillation so produced here is called undamped oscillations. This is called undamped oscillations we are getting from this circuit. It is clear? So undamped oscillation we are getting. So we are drawing a 8-stage figure in a single cycle of oscillation of resistance-less LC circuit. This circuit is called LC circuit. How is the energy is going to transfer in between L and C? For that, I am drawing 8-stage figure here. So just you see that the 8-stage figure here. Now what is that? The energy stored in a capacitor is Q square by 2C, and the energy stored in a inductance, that is called magnetic energy, that is UB is equal to 1 by 2 Li square. It is clear? Now 8-stage figure we are drawing here. Here it is our L, here it is our C. In the figure A, say initially here is L, here is C. Initially the current is 0 here. The total energy which is here, this energy is 0 initially, and initially this energy is maximum energy, and that is represented by this bar graph. So in this figure A, you can see capacitor with a maximum charge and no current in the circuit. Similarly, for the second stage, here it is the second stage. Now, capacitor goes on discharging. Discharging of capacitor with increasing current. With increasing current, here we know that the charge on this capacitor is something like this. So it will go here in this manner. Capacitor goes on discharging and energy, this energy transferred to the inductance. Say this is UE and this is UB. Bar graph is half here. Here, when the current flowing in this direction, the magnetic flux changes here and the magnetic flux will something like this here, in this manner. Say, in the third stage, what happened? Again, here our inductance, here is capacitance, then capacitor goes on discharging, all the charge on the capacitor will transfer to here, current will transfer. At this time, the maximum current will transfer here, capacitor is totally discharged and all of the electrostatic energy converted into magnetic field energy. So this is maximum here and this is 0. This is here UB and here is UE. So in the third stage, where all the, like this, you can draw here, it is the position which we are seeing here, that capacitor fully discharged and maximum current flows here. This is the stage number 3rd. Draw this diagram. Then what happened in the 4th stage? Again, show charging of capacitor in opposite direction. In the 4th stage, we are drawing a figure here. In the 4th stage, again see, here is our inductance, here is our capacitance, and the stage number 4. Now, current is flowing in this direction, this capacitor goes on again charging but in opposite direction. Or we can say here is our inductance. So in this 4th stage, where the charging of capacitor in opposite direction and current goes on decreasing. So magnetic field energy and electric field energy something like this again. Now dear children, in the next stage, say this is the figure number D. A, B, C is earlier. This D and this figure is E. Here again in this stage, say this is L and this is C. Here it is C. So in this stage, here A, B, C, and here you can see this figure. In this stage, the capacitor charged completely in opposite direction. See here. So in this figure, I can say, dear children, it is totally charged. All energy will convert it. Here is electrostatic energy. Here, in this manner, here it is UB, here it is UE, and this figure is, this is A, B, C. Earlier we have drawn. You can see in this stage the total energy is converted into again electrostatic energy, and we can say here is no energy, that is UB here. So in this stage, it shows that capacitor recharged fully with opposing polarity. It is opposing polarity. It is opposing polarity here to that of A, जो first figure था, and hence we can say here is no current. Here it is no current, so I can say here in this stage I is equal to 0. In the next stage, say here again, here is our inductance, Here is our capacitance. In the next stage, I can say again the energy transferred from here to here, but in opposite direction. So again it will go something like this. So I can say here again in this manner, in opposite direction, because here it is a negative charge and here it is a positive charge. So here we can say the magnetic field energy and electrostatic field energy is bar graph is something like this in this figure number F. Here again we say the current is maximum in this case. Again this capacitor start discharging and all the electrostatic field energy convert into magnetic field energy here. And at last I can say in the eighth stage where see here like this, here is our capacitor and here is our inductance. The current here is I. In the stage I maximum is here. In this stage current I is not maximum here. In the next stage, here in this stage the current is maximum here and the total energy is converted in this manner. Here it is UB and here it is UE, and you draw here the magnetic flux changes here in this manner like this. It will completely discharged. Current is maximum here. So dear children, see that at the stage E, capacitor discharges fully with opposing polarity to that of A. In the stage F, again listen me, it shows discharging of capacitor, that is in opposite direction, and current increasing in opposite direction. Current increasing here, current increases in opposite direction. Current increases in opposite direction, and in this stage here this is UB, here it is UE. This is the stage, I can say FG stage. This is the step G. Here all of the energy again magnetic field energy. So it shows that fully discharging of capacitor and maximum current in opposite direction. And at last of our eighth stage, again the process repeats. Here it is C, here it is L. So again I can say capacitor will charges again, current flows in this direction, it will charge something like this in this manner, and here the magnetic flux decreases, or we can say magnetic field energy decreases, and on the eighth stage again the bar graph is something like this, G, and this is H. So in the stage H again shows that charging of capacitor with current decreasing, here as shown in this figure, and we can see this cycle is being repeated again and again. So dear children, we saw here 8 stage operation of LC oscillation, how once the capacitor is charged and then the energy transferred from capacitor to inductor and inductor to capacitor. This is called LC oscillation. So in actual practice I can say, in actual practice every inductor has some resistance. Every inductor has some resistance. Every inductor has some resistance, so definitely some loss of energy is there. So effect of this resistance is to introduce a damping effect. Is to introduce a damping effect on the charge and current in the circuit. Hence, finally the oscillation dies away after some time. It is clear due to the resistance. Even if I say the resistance is zero, in a special case, the total energy of the system would not remain constant. The total energy of the system would not remain constant. It is clear? It will not remain constant. It is radiated away from the system in the form of electromagnetic waves. In the form of electromagnetic waves. In the form of electromagnetic waves. It is clear? So, in fact, radio and TV transmitter depends on this radiation. So, I can say the amplitude of oscillation goes on decreasing. Amplitude of goes on decreasing. So, it is called, or I can say they are called damped oscillations. They are called damped oscillation. So, dear children, to obtain undamped oscillation, the energy loss is duly compensated in a proper phase. Otherwise, we are getting the oscillation are something like this. So, to obtain undamped oscillation, the energy loss is duly compensated in a proper phase, and we are getting such type of oscillation. Here it is energy, here it is y, here say it is y dash. This is our x-axis, here is the time, and the oscillations are something like this. In this manner. So we can see that energy goes on decreasing. In this manner. So the frequency of electrical oscillation can be obtained mathematically. If I want to find out, so I can say the frequency of electrical oscillation mathematically I can say like this. Mathematically, the moment of the circuit LC is completed, charge on condenser start decreasing, due to this giving rise to current. Due to this giving rise to current in the circuit, as di by dt is positive, the induced EMF in L will be such that is Q by C minus L di by dt is equal to 0. This is our circuit diagram. Here is our L and here is our C. What I am telling here, the moment of the circuit is completed here, charge on the condenser starts decreasing, due to that giving rise of current, and due to this, as di by dt is positive, so the induced EMF in L will be something like that. As Q decreases, I can say I decreases. When Q decreases, I decreases. I can write here I is equal to minus dq by dt. Put this value here. So from this equation I can write, put this value of here, Q by C minus L d by dt of dq by dt. dq by dt minus sign. It is, I can write here Q by C plus L d2q by dt square. It is a double differential here. So dear children, mathematically I can write here d2q by dt square with the help of this equation plus 1 by LC into Q is equal to 0. It is the form of energy of our equation we have learned in 11th class, that is d2x by dt square plus omega square into x is equal to 0. For a simple harmonic oscillator, for a simple harmonic oscillator, this equation we know very well. So the charge therefore oscillates with a natural frequency. Compare these two, and the charge oscillates with this frequency. Omega is equal to omega square is equal to 1 by LC. So I can write 1 by under root of LC. This is equal to 2 pi nu. So the frequency oscillation in this LC circuit, that is nu barabar 1 by 2 pi under root of LC. This is all about this. Write down. So here you can say the frequency of the oscillation is given by this 1 upon 2 pi under root of LC. So is that clear, children? This is called LC oscillations. Okay.